Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through graphing linear functions. So what I'm going to do is I'm going to give you a linear equation which we've seen before, like this, y equals 2x plus 1, and we're going to turn it into a graph. But what do I mean by turning it into a graph? Well, this equation here has two variables, x and y. So as we learned earlier in the semester, if you have one equation with two variables, there are always going to be infinitely many solutions. You can't come up with just one solution for this. So for each different value of x, there will be a different value of y. So for example, if x were to equal 1, y would be 2 times 1 plus 1, which is 3. So that's a solution. X is, say, 0, then y would be 2 times 0 plus 1. If x was equal to minus 5, y would be 2 times minus 5 plus 1, which is minus 9, and so on. There are infinitely many solutions. So what we can do is display these solutions visually on the Cartesian plane. That's what I mean by graph. So how do I actually get to that point? Well, what we can do is use a table of values. So we're just going to come up with some of the solutions and plot them. So we draw up a table of values like this, and just like I did in red, we're going to choose different values for x. So it's good to have some negative and some positive. So I'll start at x is minus 2, and I'll choose these values. When you're drawing up a table of values, you can always choose these values for x. So you choose the values for x and then you substitute into the equation to find the values of y, just like I was doing. So if x is minus 2, y is 2 times minus 2 plus 1, which is minus 3. If x is minus 1, y is 2 times minus 1 plus 1, which is minus 1. If x is 0, we already know that y is 1, and hopefully you can see a pattern here. Y is going up by 2 each time. So each time I increase the x values by 1, the same thing is happening to y values. The y values are going up by 2. So that is what makes this a linear function. Each time x goes up by 1, y does the same thing. It goes up by 2. It would still be a linear function if each time x goes up by 1, y went up by 5 each time, or it went down by 3 each time. That's what makes it linear. So the reason we call it linear is, as you're about to see, if I graph these, they will form a straight line when I plot them in the Cartesian plane. So the number by which y is increasing or decreasing each time x goes up is called the gradient. So here, 2 is the gradient. So we're saying the 2 is the gradient because y is going up by 2 each time. It's not how much x is going up by, it's how much y is going up by. So the gradient is 2. Now, it's absolutely no coincidence at all that the gradient's 2 and there was a 2 in front of x. It turns out that if you ever have an equation in the form y equals something times x plus something, so the something in front of x is always going to be the gradient, and the other number by itself is going to be the y-intercept. So the y-intercept is the y value when x equals 0. So you saw here, the y-intercept is 1 because when x is 0, y is 1. So that's no coincidence at all. So now we're going to actually turn this into a graph. So we need to draw up our Cartesian plane, and then we'll plot these points. So remember, when you draw up a Cartesian plane, you have two lines at 90 degrees to each other. The horizontal line is called the x-axis, and we put arrows on it to indicate it goes forever. The vertical axis is the y-axis. That's always the case. So we can plot each of these as a point because it has an x-coordinate and a y-coordinate. So we need to first label our axes. So remember, where x and y-axis meet, that point there is called the origin. So below the origin, down here, the y values are negative, and to the left of the origin, the x values are negative. So that is how you draw up the Cartesian plane. So we plot each point. So the first point is minus 2, minus 3. So we usually write points in brackets. In fact, you have to write them in brackets. The x-coordinate is always written first, y-coordinate written second. So to plot this point, I go across to x is minus 2, which is here, and I go down to y is minus 3. So that will be there. Okay, then do the same thing for the next point, which is minus 1, minus 1. So I go to x is minus 1, y is minus 1, which is there. 0, 1, so x is 0 is at the origin, and then I move up to y is 1. Then the point 1, 3, 2, 5, and 3, 7 will be all the way up here. So note that all of the points lie in a straight line. So on this line are all the possible solutions to y equals 2x plus 1. Remember, there are infinitely many of them. So when you've plotted the points, all you have to do is draw a line that goes through them all. Yours will be nice and ruled. I can't really use a ruler on my iPad. And there you go. That is the line y equals 2x plus 1, the set of all solutions to y equals 2x plus 1. So the gradient being 2 means each time x increases by 1, each time I go across 1, I go up 2. So across 1, when x is increasing by 1, I go up 2 because the gradient of this particular line is 2. And that is all there is to it. So each time you're given an equation, you can just draw up a table of values like that, substitute in the y values because you choose the x values, plot them and join them up. Easy as. All right, this has been the luckiest maths teacher in the world. Have a great day.